All right, let's dive in. Today, we're talking about the absolute heart of any decentralized network, its consensus engine. It's the magic that lets thousands of computers that don't trust each other all agree on a single source of truth. It's literally the engine that makes the whole thing go.
And to really get why this is such a big deal, we have to start with a really basic problem. Think about it. Any digital file, whether it's a photo, a document, a song, it's just data. You can copy and paste it a million times. So if digital money is just a file on a computer,
What's to stop you, or me, or anyone from just hitting copy and paste? What stops you from sending that one digital coin to your friend and then sending that exact same coin to a store a second later?
well, that is the multi-billion-dollar question. It's called the double spend problem. And it is the single biggest hurdle that any digital currency has to clear to even be taken seriously. I mean, if you can't solve this, you don't have money. You just have a text file that's really easy to copy.
Now, in the traditional world, the solution is pretty simple, right? Banks. Your bank keeps the one official record of your money. They get the final say. But the whole point of blockchain is to work without a bank, without that central trusted party. So, how in the world do they pull it off?
They do it with something called a consensus mechanism. And today, there are really two main ways of doing it, two different philosophies for building trust in a trustless world: proof of work and proof of stake.
You can really boil the difference down to this. Where does the security come from? With proof of work, security is bought with real-world physical cost. Think of it as security backed by energy. Proof of stake, on the other hand, is security backed by locked-up capital. It's security backed by money. Two very different paths to the exact same goal.
Okay, so let's get into the nitty-gritty. How does proof of work actually, work? Well, imagine a constant global competition. These participants, we call them miners, are all using these super powerful computers to race to solve an incredibly difficult math puzzle. The first one to find the solution gets to propose the next block of transactions and wins a reward. And here's the clever part: once they find the answer, everyone else on the network can check it and see that it's correct almost instantly. But, nothing's perfect. There are definitely trade-offs. The big strength of proof of work is that its security is literally tied to the real world through the cost of electricity. It's been running and battle-tested for more than a decade. But that strength is also its biggest weakness. It uses a ton of energy by design, which can push the system towards these huge industrial-scale operations that cluster around places with cheap power.
Now, proof of stake flips the script completely. Instead of a frantic race, it's more like a lottery. Here, participants, we call them validators, lock up their own coins as collateral. They're putting skin in the game. Then, the network's rules just choose one of these validators at random to propose the next block. If they do a good job, they get a reward.
And of course, this way of doing things comes with its own set of pros and cons. The most obvious pro? The energy savings are just massive. Plus, if a validator tries to cheat, the network can punish them directly by destroying or slashing their collateral. The weaknesses, though, are different. There's a concern that the rich get richer, since having more coins staked gives you more chances to be chosen. And a lot of people delegate their stake to big companies, which can create its own form of centralization.
Okay, so we've been throwing around terms like miners, validators, and nodes. People mix these up all the time, but understanding the difference between them is absolutely essential if you want to understand how these systems really work.
Let's start with the most important one to get: the node. A node is basically any computer out there that's running the network's software. Its job is not to create blocks. Its job is to be a referee. It downloads every single transaction, every single block, and checks to make sure everyone is following the rules. They are the ultimate guardians of the system. Next up, the miner. Now, this role only exists in proof of work. Miners are the ones who actually produce the blocks. They're the competitors, the ones burning all that energy to solve the puzzle and earn the right to add the next page to the ledger. And on the proof of stake side, the block producer is called a validator. Instead of earning their spot through raw computing power, they're chosen because they have capital staked as collateral. Their job is to propose new blocks when it's their turn and to confirm that the blocks proposed by other validators are valid. So if you remember one thing from this section, make it this simple phrase: producers propose, nodes verify. That's it. The miners or the validators, they get to suggest what the next block should be, but it's the thousands of independent nodes all over the world that have the final say. The producers don't have absolute power. The real power lies with the verifiers.
But what happens when that system of checks and balances gets threatened? What happens if one person or one group gets control of the majority of the power to produce blocks? Well, that leads us to the most infamous scenario in all of crypto, the 51% attack.
51%. That's the magic number. If an attacker can somehow control a majority of the network's consensus power, whether that's mining power or staked coins, they can start to seriously mess with things. Okay, this is super important because people get this wrong all the time. Let's talk about what an attacker can and maybe more importantly, can't do. They can potentially rewrite the most recent transactions. That's how they could double spend. And they could block other people's transactions from getting through. But what they can't do is just create new coins out of thin air. And they can't steal your coins unless they also steal your private keys. The fundamental cryptographic rules of the system still hold.
And this is where we see the fundamental economic difference in stopping these attacks. To attack a proof-of-work network, you have to pay a massive, ongoing electricity bill. It's a constant drain of money. But to attack a proof-of-stake network, you risk having your giant pile of staked money just destroyed by the code itself. It's an attack that could literally make the attacker go broke.
So you might be hearing all this and trying to decide, okay, which one's better? But the truth is, it's not that simple. Decentralization isn't just an on or off switch. It's really a spectrum, and it has a whole bunch of different layers. When you really look at a network, you have to examine it from all these different angles. How spread out are the miners or validators? How many people are actually running their own nodes to verify the rules? Is everyone using the exact same piece of software? Who actually gets to decide on changes to the protocol? And is all the infrastructure everyone uses also decentralized?
And all of that leads to this one really critical idea. A network is only as decentralized as its most centralized layer. Think about it. You could have 10,000 validators all around the world, but if every single one of them is running their hardware on the same single cloud provider, well, how decentralized is that, really? It's a question we always have to be asking.
Okay, let's bring it all home. What are the big takeaways here? Number 1, consensus is all about solving that double spend problem without a boss. Number 2, proof of work secures the chain with energy, proof of stake secures it with capital. Number 3, producers propose, but it's the nodes who are the ultimate referees. And 4, decentralization isn't just one thing, it's a whole spectrum of different factors.
And that leaves me with one final thought for you. We've spent all this time talking about the technical side of things, the protocol. But at the end of the day, these networks are made up of people. So what do you think is more important for the long-term health of a network? A technically perfect, decentralized protocol, or a deeply decentralized and passionate community that's committed to its values? Something to think about.